Okay, hello everyone. Welcome to our Real-Time Data for Real-Time Decisions webinar. My name is Abby Bauer. I'm an editor for Hoard's Dairyman magazine, and I will serve as today's moderator. This event is brought to you by AB Vista and Dairy One, and we are proud to partner with them on this webinar. You will learn more about these two companies in just a few minutes. Everyone in the dairy industry knows how important high-quality feed and a well-balanced ration are for optimizing animal health and milk production, and forage quality testing is a vital part of that equation. Forage samples taken on the farm can be sent to a certified laboratory for thorough analysis and accurate results. But now it is possible to get results even faster right on the farm. Today we will learn more about one of these opportunities, the NIR for farm, and how it could be incorporated into your dairy's feed management plan. This session will include a few short presentations, followed by an opportunity to answer audience questions. If you have a question to ask one of our presenters, please type it into the questions section of the GoToWebinar control panel, and we will address those later on. Our program for the day includes 3 knowledgeable speakers who are coming to us from Kansas City, Central England, and New York State. To give you some background information on AB Vista and Dairy One, our first webinar guest is Bruce Hageman, the Ruminant Manager for AB Vista. Bruce has enjoyed a long career in the dairy industry with experiences in ruminant nutrition, milk marketing, and large farm leadership. He has a 360-degree view of the industry as his career has spanned 3 decades in sales and marketing of ruminant nutrition products with Church & Dwight, Diamond V, and now AB Vista. In addition, Bruce has previously served as Vice President of Farm Services at Dairy Farmers of America in Kansas City and General Manager of 4 large dairies in the Southeast, milking a total of 9,100 cows. Bruce, welcome to the webinar.
Good day, all. On behalf of our company, AB Vista, I'd like to welcome you and thank you for attending our webinar focusing on near infrared reflectance, or NIR for short. You may not have heard of AB Vista, but we are a UK-based company, a division of AB Agri, which is in turn a division of Associated British Foods. We operate through individual entrepreneurial business units empowered to grow their interest independently and through a strong network of contacts across the entire food supply chain. Our organizational structure allows us to decentralize decision-making to the local level, giving our people the autonomy and authority to act quickly to best serve our customers. Our businesses and brands are clustered into 6 distinct business groups: AB Connect, AB Vista, New Ventures, Specialty Nutrition, Frontier, and AB Agri China. A balanced portfolio of businesses spanning the entire food supply chain gives us a breadth of skills from which we can develop new products, new ideas, and new propositions for the ruminant market. And while we are an established global monogastric nutrition company, our current focus is on growing our ruminant nutrition business. Very quickly, here is our product portfolio at this time. VistaCell, which is our live yeast for improved rumen pH, better fiber digestion, and productivity. Vista Pre-T is our forage pretreatment for greater fiber utilization. Optipartum C is another feed additive in our product line to increase nutrient digestibility. And Accelera C is a highly digestible lactose pellet for calf rumen development. And of course, our NIR for farm, which is our portable NIR forage analysis tool, which we'll be discussing today. Our goal is to work collaboratively with customers to bring new insights and technologies. We do this through research and understanding of rumen physiology, exploring the diet in terms of the substrates and how they impact the animal, and finally, trial and research around mode of action of our products, as well as optimizing their application commercially. NIR plays an important role in all of this in terms of understanding the diet as well as optimizing product application. We now have our first poll question on the screen. So we'd like you to please answer the question that's up there. What is your role on the farm? And as you can see, we have 5 options, 5 selections. One is producer, nutrition consultant, veterinarian, researcher, or feed company, or associated with a feed company in any way. We'll take a few more seconds here and allow everybody to choose the option and the answer that best fits your role on the farm. Okay, I think we're probably there, and here are our results, just to give everybody an idea. Looks like we've got a large attendance today from our nutrition consultant friends, about 40%. Researchers making up the next largest category at 34, and then kind of lumped in together producers, veterinarians, and folks from feed companies. So once again, welcome to all of you. We thank you. And regardless of which of those areas that you might fit into, or even multiple areas potentially, we think you'll find some real benefit and real value to what we're going to talk about today. So as we're all aware, the traditional approach to forage analysis has been to collect samples, ship to a qualified lab, process the sample, then review and react to the results days later. The beauty of near-infrared reflectance, NIR, technology is that we can analyze samples on farm, obtaining real-time results. Over time, these results are as accurate as those from the lab, allowing us to make immediate changes to the ration if necessary. Another significant benefit to NIR technology is the ability to scan and analyze silage samples at harvest, maintaining awareness of dry matter variances at the beginning of the ensiling process. We have worked closely with Dairyman in the early development of our North American calibrations. At AB Vista, we are continuing our relationship by partnering with Dairyman to distribute and support our NIR for farm technology. And as you can see on the slide, AB Vista is primarily responsible for hardware, for software, and then we work together. We collaborate on the calibrations in developing and finalizing those. So there's the highest level of confidence between Dairyman and AB Vista in the final product. And Dairyman's specific responsibilities then are distribution of the physical product, sales and technical support, and then whatever product training is necessary to follow up.
Thank you for providing that insight, Bruce. Next, we will turn our focus to near-infrared or NIR spectroscopy, a method utilized to analyze forage quality. Sharing more on this topic will be Chris Piotrowski, who is currently a director at Near, a leading NIR calibration development company that is part of AB Vista. He has been working in the feed industry for 40 years. As an analytical chemist by training, Chris introduced the first NIR network in the UK in the 1980s. He now leads the technical development of NIR calibrations and applications at Near and has been instrumental in development of near-infrared calibrations and applications on the farm to the animal nutrition market. Chris is widely recognized globally for his contribution to the development of NIR calibrations for agricultural applications, including many novel applications based in animal in vivo studies. We are pleased to have him as part of today's program. Chris, the floor is yours.
Thank you. I thought I'd start the presentation by showing you what the world would look like if we could see near-infrared light. And we would see a world of vibrating molecules. And these vibrations occur when we irradiate a sample with near-infrared light, we excite the bonds, and if the bonds are flexible enough, we will see a vibration. And those bonds tend to be organic in nature. So it does mean it gives us the opportunity to measure things like carbohydrates, proteins, fats, and dry matter. Many of you may be familiar with what we refer to as the benchtop instrument, and these NIRs have been around for many years now. And whilst the manufacturers may bring out new models every now and again, the actual world of the benchtop instrumentation hasn't changed much in the last 20, 30 years. But what has changed is the influx of new portable NIRs into the market. I'm just showing a selection of portable NIRs that I just sort of screenshot from the internet. And to be totally honest, I could have put 3 or 4 slides together with a number of different instruments out there. And we tend to see these instruments hit the market on a regular basis. So it's important to understand what makes a good instrument. Not all instruments are the same, and not all NIRs will perform the same, given what they're capable of. So it's important to understand exactly what you're getting when you purchase a portable NIR. And one of the majority of handheld NIRs work on a smaller wavelength range. In a spectrum from a benchtop, which is the light blue spectrum, and overlaid on that is the spectrum from our NIR4. So you can see we measure from 950 500 nanometer range. You're tending to generate quite a lot of heat, so you need things like fans and sealed units, and that puts a lot of weight and mass into the NIR. So because of the size and because we want it portable, there is some reduction in the wavelength range that we can measure. The picture there is an example of our NIR4. And why does it matter that we're measuring different portions of the NIR spectrum? On here, I've mapped out exactly the vibrations and where they occur in that NIR region. And if you just look at the very top line, the blues and the grays here, this is where water or hydrogen attached to oxygen absorbs. So you can see it absorbs in many different places along that NIR spectrum. So we're not just trying to measure water in one place. We get many opportunities to measure water. It's either in a combination or an over vibrations that occur in the mid IR region. Light blue. And again, the light blue spectrum is from the benchtop, the lab-based instrument, and the dark blue spectrum is from the portable NIR4. And again, you can see that whilst we don't measure water in as many places, we still get to see water and protein in 2 different places on the portable NIR, as opposed to 4 different places on the benchtop. So although we don't get to see as many vibrations, we do get to see the important vibrations and areas where we can measure those. And provided we get a good spectrum, that will allow us to build a good calibration. So in this slide, on the right-hand side, you can see the NIR spectra from the NIR for farm. And this is grass silage. There's actually over 1,000 spectra in that picture. But I think you can see just from the shape of those spectra how clean they are. There's not a lot of noise in the spectra. And you can see that very large peak that appears on that dark blue patch, which is where we see the primary absorption for oxygen and hydrogen. So that's where we would measure dry matter. But also to the right of that in the light blue is where we can measure protein. So you can see these protein and water peaks appear. And that gives us an excellent opportunity to produce a good calibration. And again, this is just for dry matter in grass silage, just as an example. The R squared 98, so 98% of the population will fall within 1.4 standard errors. So it's a very precise and very accurate calibration. And it's worth mentioning here that this is how Dairyman have partnered with us, and Dairyman are now adding North American samples to this database to ensure that what we're measuring is applicable to the market. And they're constantly adding new data to the calibration so that we can build a model. And you can see just from the left-hand side that it's a very linear model covering dry matters from 20 to over 70%, all in one calibration. And we're all aware that error in our measurements are a very important thing, and I'm sure many of us will have sent off 2 samples to 2 different laboratories and got very different results. And so I think it's worth just exploring a little bit about the sampling and how we've engineered the NIR4 to actually eliminate as many of the sampling problems as we can. So we're not just talking about the piece of hardware, we're talking about a complete application that has software designed and engineered to give us the best results possible, and calibrations with partners like Dairyman who give us the highest accuracy. And when it comes to looking at error, they tend to come from 3 areas. The primary sample is largest, then the subsample in the lab, and finally the calibration. And one thing that we can control and one thing that we can engineer a solution for is that sample preparation when it actually gets to us and we want to measure the sample. So be it a sample in a lab or be it a sample on farm, we need to have a method of actually making sure we make the most accurate measurements when we're working on that sample. And in this experiment, we took a very large 10 kilogram bag of silage and we subdivided it into 20 500 gram samples. We analyzed this on a benchtop, and what we did, we analyzed each sample singly, and in the table I've reported the difference between the highest and the lowest reported results for the key parameters. So for TDM, total dry matter, for instance, we had a 6.6% difference between the highest and lowest recorded result. Then we took those samples and we analyzed the samples in duplicate, repacking each sample and then averaging the duplicates before we calculated the difference between the highest and lowest. And you can see we see a significant drop even just on duplicate analysis. We took it further, we did triplicate, quadruplicate, and quintuplicate measurements. And you can see once you get down to taking 5 subsamples and averaging that subsample, you'll get into a very accurate and precise figure. So we've actually engineered that into our solution. So every time you take a measurement of the sample, it actually collects 100 spectra for a scan, and we do 5 scans in 5 different positions before we average those to give the predicted results. So we've engineered into the solution the ability to minimize the sampling error. We also make the operator take a reference tile scan before every sample, and that reference tile allows us to deal with environmental differences. So whether it be a hot day, hot sample, cold sample, by taking that reference tile before we do the measurements, we can actually adjust the NIR spectrophotometer to cope for environmental changes. Again, it's another way we've engineered that into the solution. Is a saying by Mark Twain: lies, damn lies, and statistics. So I think you'll fathom out that the next slide I'm going to put up will have a statistic on it. And again, this is important. This is looking at the primary sample. So when we go on farm and take a sample, how sure are we that we're getting a good representative sample? And there's this very simple stat: 2 times the standard deviation by the square root of the number of samples we take will allow us to observe the accuracy of the measurement we're going to make. So I think many of us, when we go onto farm, we will subsample from different points in the clamp, bulk those samples together, and then again subsample to have a sample that we can send to the laboratory. In this experiment, we actually took the measurements at each of these sampling points. So we had 10 sampling points, and we actually took the dry matter measurement at each sampling point. And you can see the difference between sample 2 and sample 9. We've got a 29% dry matter and a 39% dry matter. So 10 units of dry matter difference between those 2 samples. And if we don't adjust our rationing for that, then we're not doing a particularly good job in giving advice to the farmer. So it's important that we understand the variability on farm and we're able to adjust and have knowledge that we're making the best we can. So again, just using that statistics, I've calculated the average and the standard deviation, and if you pump that into that equation, if we took 8 samples, then we're within plus or minus 2.8 units of dry matter. If we only took 2 samples and averaged those and sent them to the laboratory, when we got the results back, we could be plus or minus almost 6 units of dry matter away from what is the true average of that silage bunker. And I think even Mark Twain, who was a great observer of life, would understand that what that simple statistic tells us is that the more observations we make, the better we understand what we're trying to measure. If we only ever take 1 observation every time, we'll get limited information. And when we looked at that silage clamp, that was what was across the face. You can imagine as we go through the clamp or the bunker, then that variability can be even bigger. So it's so important that we have a tool that will allow us to take more and more measurements on farm. So again, coming back to our error matrix, when we're on farm, we want a technique or we want a tool that'll allow us to take as many samples as possible. Sending samples to laboratory can be quite costly. If we have a technique that allows us to do it on farm real time, it'll allow us to gather more observations and more information. We've engineered into the solution a method that will deal with the preparation and sampling of the actual sample presented to the NIR. And our links with Dairyman allow us to make sure that the calibration is monitored every time, and we have a constant flow of real sample data to update the calibrations, new season data, new geographies, new varietal data. That's what Dairyman has given us when they help us to build these calibrations. So innovation doesn't have to be something new. it can be a different application for a better solution. And what we've done with NIR4 is we've engineered a solution that provides us a different way of taking measurements on farm, a better way, a more accurate way, and a way that we can give more information direct to the farmer.
Thank you very much, Chris, for explaining this technology. I think we can all agree how important feed quality is to milk production and the farm's bottom line. So the ability to be able to test forage quality with accuracy is such a valuable tool. Remember, if you have any questions for our speakers, please type them into the questions section of the GoToWebinar control panel, and we'll answer them toward the end of the webinar. Next, we'll hear from Sarah Fessenden, who grew up on a medium-sized dairy farm in central New York State. She graduated from Cornell University in 2015 with a bachelor's degree in animal science and a focus on dairy nutrition. Sarah has spent most of her career in her home state of New York, with the exception of a few years working as a dairy nutritionist in Wisconsin. She now works at Dairyman Forage Laboratory as the business development manager for the Forage and Soils Laboratories. Outside of work, Sarah is a member of the planning committee for the New York State Fair Birthing Center. Sarah, please proceed with your presentation and tell us more about the services provided by Dairyman.
Thank you, Abby. Thank you everyone for joining us today. We're really excited to share some of our research and updates with you as well. So today I'm going to run us through a few different topics. First, I'll touch on Dairyman's background and kind of what we're bringing to this project, as well as the Forage Lab expertise in particular. I'll focus mostly on some on-farm examples we've had over the past few years, and then I'll touch on a value proposition for the instrument itself. So a quick introduction to Dairyman. We're a farmer-owned cooperative that represents over 3,000 farms and over 600,000 cows in the northeastern U.S. We have a board of directors that governs us, and they work with conjunction with our management to make decisions to bring value back to our membership. We're also closely affiliated with DFA. We're a member organization there, and we have significant business with them. Dairyman itself, we like to represent our business with this graphic. We measure everything you need to manage your farm, from sunlight and water through the farm to what leaves the farm in terms of milk and manure. Today we're focusing mostly on the center of this graphic, Forage Lab. We like to test everything with crops, mostly feed for nutritionists, and then also we do dabble with some manure and plant tissue services as well. Services at Dairyman are held in a few different buckets. We have our agronomy services, which covers our soils laboratory, our sampling services, scouting and mapping. We have a DHI improvement, milk analysis records, and DHI testing. We have our forage laboratory, which tests feed, forages, water, manure, plant tissue, and also hosts our NIR affiliate network. We have our integrated farming solutions team, which has software and hardware for the farm. And then we have a few other lab services, including milk and blood pregnancy testing, Yonis, BVD testing, bacteria and regulatory testing, and then also our checkmark quality services. We have a few labeled brands within our business, including the ACS brand for our nutrient management planning and crop consulting, our Finger Lakes Laboratory, which tests wine and juice analysis, and then Equine Analytical and Aquarius are underneath the Forage Lab, offering testing services for equine and exotic markets. Going further into the Forage Lab and what we're offering to help this project with AB Vista, the milk lab for Dairyman started back in the 1940s, and then they added the Forage Lab in 1974 as they saw the testing needs for forage rising among their customer base. And then focusing on our NIR analysis, we introduced that in 1982, and we've grown and strengthened our calibrations since then. A strong marker of that is our NIR affiliate network. We licensed our calibrations and we began working with other labs starting in 2008. We've seen really great growth and volume out of that. In 2016, our affiliate network surpassed 100,000 samples in volume. And as of today, we're representing over 25 labs, each with a few of them representing multiple instruments. So we have about 35 instruments connected worldwide on this network. So touching on our calibration development in-house, our calibrations have been created on FOSS instruments for over 30 years. We had hundreds of thousands of samples based on our reference chemistry that we perform in-house. We have developed across numerous components and feeds, from corn silage all the way to fish. So our role in this partnership with AB Vista is to take the calibrations they have developed for the NIR4 and add the North American bias. These calibrations are separate from our lab calibrations. We're bringing our expertise from those to support this partnership. So moving on to examples of how we've seen the instrument used on the farm. We've been running beta testing and preliminary studies for a number of years, starting with dry matter only calibrations and recently moving into the full nutrient profile that's currently offered. We don't currently see this as a way to replace your lab analysis, but as a way to supplement the current analysis that you're doing. It brings the lab to your farm and acts as a sentinel device to measure more observations and allow for more precise rations. So we'll move into our first poll question, which is, how do you currently test dry matter on your facilities? We have a few options on the screen. You have Coster tester, a portable NIR, possibly different than the NIR4, a dehydrator, do you use your lab test, or another option. We'll give you a few minutes to put in any responses, and then we'll take a look at the results. All right, looks like we have our results. Looks like about half of our participants currently use their lab test for their dry matter values. And then we have about a quarter using a Coster tester, and then an organization across the others. Pretty high response on the other percentage, so I'm curious what people are using there. If you want to put any of that in the chat, we have that available, and I'd be interested to see responses. So moving into our examples, touching first on just the dry matter calibrations, our first beta test was looking at dry matter monitoring on a particular farm close to us. We had selected them because they were already testing their dry matter twice a week. As you can see in this graph, which is an example of the graphs that are generated on the web portal, a unique feature for the NIR4, he scanned multiple times per day to gain confidence and then tracked that over time. So if you look to the left on the scale, it's a little misleading. The variation on the dry matter is actually quite small. He did eventually abandon his previous method in favor of the speed and accuracy of the NIR4. Moving into our next poll question, how often do you dry matter test? And we have a few options available: daily, weekly, biweekly, monthly, or other. And judging by the previous results, if it's lab testing, if everyone's doing dry matter tests weekly and doing a lab sample weekly, that's really good for the labs, but I have a feeling we're going to be pushing that dry matter value out a little further. So we'll give a few more moments for responses, and we'll take a look at the results. Okay, looks like we do have a fair amount that are doing weekly tests. That's very good. And then we also have a few using daily. Very excited to see that number so high. And then we have 23% on other. Again, I'm very curious what that value is. So if you guys do want to send it through the chat, I'm going to be looking for it. Moving on to our next example, another great value that we've seen for dry matter testing is in harvest decisions. For the past few years, I've been working with local cooperative extension teams to offer dry matter testing on fresh corn silage and to help estimate harvest time. This graph is showing a day when we received quite a few samples in a very small window and came to really appreciate the speed of the NIR4. So all the samples that we took at the site were tested both by the NIR4 and then the Koster tester. And then we brought the samples back to the lab to do a lab dry matter using that as our gold standard. So towards the end of the day, we started to get a lot of samples quite quickly. And so we shortened the drying time and the weight of the Koster tester samples. And that's where you can see the Koster tester really starts to fall short. The biggest error in Koster testers is the human error. And so that caused some pretty great variation that would drastically affect harvest decisions. So an example of one of these, 37% dry matter versus a 28% dry matter will lead to a very different conclusion on when to harvest your corn silage. Our next example, we've recently begun offering and testing more expansive calibrations, including all the values that are shown here. Again, this is a graph that's pulled off the portal where you can track your changes over time. This is a testing farm that we've been using, and you can see they've been tracking the same feed for a series of months, and it speaks to the size of the farm that you can see such regular feed there over, looks like 2 or 3 months. So they did a few scans per day that shows how repeatable the instrument is. And a feature to note on this portal, this graph can get a little bit noisy with all the nutrients, and especially the ones that are lower in quantity, such as ammonia or VFA or lactic. And so in the portal, you can select which parameters you would like to view, which is from the drop-down menu that you can see in that middle green tab. We see the value of being able to track the changes, particularly on signal nutrients like starch and fiber. These signal nutrients are the ones that I use when I'm making decisions on farm when the NIR4 analysis should signal to send a sample back to the lab for further analysis. So an example of these signal nutrients at work was on a farm this past fall. The farmer was demoing one of the NIR4 instruments and had some doubts on the performance. He had lab analysis from a haylage sample that had been pulled 2 weeks prior, and when we analyzed with the portable device, the results were quite different from the lab results, especially NDF. The farm had marked where their new cuttings went in on the bunk walls, and we learned through the NIR4 that they had been feeding the next cutting for over a week without realizing it, as the bunk wall marking wouldn't be reached for a number of days. When the nutritionist adjusted his ration software to the new values, the software predicted much closer to what the cows were actually telling us. So had he been able to make that ration adjustment a week earlier, that could have been some optimized performance that he missed the value of. Our final topic will be just touching on the value of doing a regular analysis with the NIR4. So even just speaking strictly on dry matter, we know that dry matter changes have the greatest impact on performance, and it's also the nutrient that changes the most. Without tracking these changes, the effect on performance is always negative. So in this example, I took a few different diets that I had previously fed and I averaged out the cost of them. The values are probably a touch dated now, but I was pretty conservative in it, so we'll just use this as pretty ballpark numbers, if anything, a little below what the true value would be. So in this example, when the same as-fed quantity is fed, the following would happen. If your dry matter decreases, unrecognized by the farmer, less silage dry matter is fed out and the cow is left with no feed for a period of time, and then your milk yield will decrease. If there's a dry matter increase, which also goes unrecognized by the farmer, more silage dry matter is fed out, and the cow can't eat the additional quantity dispensed, assuming that you've already fed to the max dry matter intake allocation. The daily concentrate allocation is also then mixed into the additional silage volume, and so your milk yield will decrease and feed is also wasted, including more valuable pounds of concentrate. So when calculating the feed cost, I priced out those diets as I had mentioned. I did give a value to your homegrown feeds. Always should give those a value, especially when you're optimizing in a ration. That came out to about 8 cents per pound, and the average concentrate cost was 20 cents per pound. This was based on Wisconsin diets, so I know those values would be different in different parts of the country, especially the proportions of feed fed. So in this particular example, if the feed was 3% drier, I saw about $101 of wasted feed. Oh, and this is all based on a 500 cow herd. And then on a 3% wetter diet, we saw no wasted feed, but the lost milk. And I got those milk prices off the milk pay calculator from Adiseo. I use pretty average herd demographics at 75 pounds per cow per day at 3.5 fat and 3.0 protein. So if we assume there's an equal number of these dry matter events over the year, that was an average loss of $745 for those 3 days on a 500 cow dairy. So taking that math out a bit further, if you assume this happens once a month, that you lose track of your dry matter just for 3 days, averaging $745, that's $9,000 in waste per year. And I think losing track of your dry matter only 3 days a month is pretty conservative, and I'd guess a lot of farms won't want to admit it, but there's probably more days a year that they aren't aware of dry matter changes. I think if you simplify this further, it came down to about 50 cents per cow per day in loss if you don't know what your dry matter changes are. So with that, I'd like to move into the next segment of our webinar. I've put my email up on the screen. I know it's also in the chat. If you have any questions or you're interested in scheduling an in-person demo, feel free to reach out to me. I'm very interested to engage with you. We do also have a survey at the end of the webinar that would provide contact for us to reach out to you if you do have more questions.
Thank you, Sarah. Certainly appreciate you providing that close-up look at sampling and how it can be utilized on farm. We did have a few people that put in answers as to what they use for dry matter testing. Air fryers was one answer, and a commercial drying oven was another. So give you a little bit of an idea of what people are utilizing. Next, we will go through an actual scan of a corn silage sample to show you how this technology really works. Sarah, can you please walk through that sample for us?
Yep. So a big feature that we like to highlight with the NIR4 is that it's taking a dynamic scan. As you'll see in this video, we're moving over the sample throughout the sampling process. We see other instruments in the market that are really more of a point and shoot method. We find our method is more accurate and repeatable as you're covering more of the sample. That's also why we like to use more surface area with the calf bucket shown here. The unit does come with a collapsible bowl, which is good in a pinch, but we do recommend using something a bit larger to cover more surface area if you can. The analysis itself, as Chris said, covers over 100 scans throughout the process and then averages that in the results. As you can see, it takes less than a minute to get those results as well. And we'll be zooming in on the screen to show you the specific parameters and how that will look. A feature to note is that there's a traffic light notification system. Those will show up if any parameters are drifting too much from acceptable variation, and they'll light up once you complete 6 scans. As you can see here, soluble protein is the one that's highlighted as moving slightly out of parameters.
That was very helpful. Thank you, Sarah, for taking us through that example. Once again, I would like to thank AB Vista and Dairy One for providing today's program. And at this time, we will open the floor for audience questions. I'll ask all of our presenters to please turn back on their video cameras so that we can participate in this session. So the first question here, and Bruce, if you're, there you go. We have everybody. All right, so the first question is, how often are the calibrations updated, and how does that work with the equipment? Like, how do you get the updates to the equipment on your farm?
Shall I take this one? So yeah, we try and do updates twice a year, particularly after harvest time when we see the biggest changes between harvests. So Dairy One will be collecting data and sharing that with us so we can look to see if we need to do a calibration update. If we need to, what happens is we build the calibrations and then we publish the models onto the web portal. Once those models are published, then you synchronize your device with the web portal and it will download the latest calibrations direct onto your instrument and tablet.
Yes, and as long as you're connected to Wi-Fi, those updates will be automatic. So it's a pretty easy system.
Thank you both. The next question, could one of you review what variables this technology can measure in addition to dry matter? Is there NDF, digestibility, protein? What else can be determined?
Yes, I can. I'm just trying to pull up my graph because I always forget which versions we have of each one. Sorry, this is getting a little small. I believe we have the NDF, the ADF, lignin, lactic, ammonia, VFA. Oh, my screen's moving. So we have crude protein, degradable protein, soluble protein, WSC, NDICP, ADICP, and then fat and ash.
Good, thank you. Here I have a comment and a question that I will send to Chris first. It says, I love the product. I feel it's the best in the industry. When will the Bluetooth wand become available?
It's a good question, yeah. The Bluetooth wand is available. It's something we've been working on and running alongside in parallel with the wired version. And you know, we've done all the testing to make sure that it's as compatible as we can. And you know, we're just looking at when we should start to roll that out. So we've got the instrument working, everything's right, and we're just at the very early stages of rolling that out.
Okay. Next question, I think maybe Sarah or Chris would tackle this. If NIR4 predicts a value of 20% crude protein in fresh material, how close is that prediction to the wet chemistry value of percent crude protein in the dry matter or dry material?
Yeah, sorry, not quite understanding. So if it's 20% in, oh right, sorry, if we measure on a fresh material and it comes out 20%, and you took it to the lab and dried it, how close would it be to that? Oh, sorry, yes. Pretty close, to be honest. The error around the protein calibration is plus or minus 0.6, 0.7, so it would be within 0.6 or 0.7 of the dried protein value in the laboratory.
Thank you. Bruce, we have a question on the cost. Is this, if you maybe want to give a ballpark or just some comments here?
Yeah, I think I'll defer to Sarah on this from Dairy One, but I know they have multiple packages and multiple price points. It really is, I think, kind of customized to what the individual wants. But Sarah, maybe you want to fill in a little more detail on that.
Yes, so we do have some promotional pricing going on right now, especially with that Bluetooth wand coming out. We have early adopters, discounts, and bulk discounts available. So we can talk to you each individually if you do have an interest, just to kind of set the understanding. This unit is a precision instrument on your farm, so it's a higher price point than some may be familiar with. So you're looking at about $20,000 to start, and then a yearly calibration cost.
Thank you for clarifying that. The next question is, what is the panel's opinion on using the Brix index in forage analysis? I don't know, Sarah, if you want to go first.
Could you repeat the question, please?
Sure. It says, what is the panel's opinion on using the Brix index, so BRIX index, in forage analysis? If anyone has any comments on that?
Is this for the sugar measurement? Is this Brix as in brick sugar? Sorry, I'm a bit unfamiliar with some of the measurements, but that's the only one I've come across.
I think that's right, Chris. Yeah.
Yeah.
I've mostly seen Brix used for testing milk and milk replacer, not as much on the forage side.
Good to know. A question here, what methods are behind your soluble protein data? I think that would be Sarah.
For the calibrations, that would be more on Chris's side. Soluble protein for wet chemistry at our lab, we use the Dumas method, and we do publish all of our methods on our website as well. These calibrations are developed separately, so our lab calibrations are separate than the NIR4 calibrations. So I'm not sure which soluble method Chris's are based on, so he could take that one.
It's based on your data, Sarah, so whatever your reference method is will come through into to our NIR. You've provided all that data to us, yeah.
Okay, yep, then it would be the Dumas method, and we use LIGO instruments for that.
Thank you. Someone is asking, will my NIR S4 with a UK calibration also work in the US? Chris?
I mean, it will, but we know we had to improve it with US samples, and that's the whole idea behind our partnership with Dairyman. Dairyman have given us access to those North American samples, both in terms of different geographies and different varieties. So they were added to our UK-based calibration, and so we now have a more universal calibration. It covers both the UK and the US, and we've also partnered with other laboratories in New Zealand, and so we have some New Zealand pasture land calibrations that come from there. So in the different territories, we know we have to partner with a very good laboratory to help us improve the calibrations by providing sample data from that region.
Okay, and that ties into the next question. Someone was asking, can fresh forage like pasture samples be analyzed even though they're very wet?
Yes.
Yes.
That was included in the one example I provided of using the Koster tester on the fresh corn silage. Fresh haylage we haven't tested quite as much, but we do see that performing just as well. The fresh corn silage has been spot on. It's really impressive how well that one performs.
Thank you. Question here says, what NIR spectra is covered? Chris, could you touch on that one?
So again, I mean, the NIR range that we're covering with the NIR for farm goes from 950 nanometers to 1450 nanometers. So that covers quite a range of the spectrum. So, primary absorbers like protein, dry matter, fats, starch are all appearing in that wavelength range. So the majority of the proximates, including some of the fermentable products such as lactic acid and whatnot, are covered in that range. So it's a very, very good range, particularly for wet forages, because sometimes as you move up into the higher area, the NIR region, you can get saturation from very wet samples. So the range is designed really to give us maximum amount of data at a point where we don't reach saturation in the NIR spectrum.
Chris, would that be a good way for people wanting to compare competitive products to look at that feature and to ask that very question?
Definitely, the range is very important, and as I said, it's important that you cover not only the main absorbances, but you get to a point where you're not saturating with high or very wet samples. I mean, it is a quite typical range, but we do also see portable NIR instruments that only measure between 800 and 1100 nanometers. So, that it really is quite a small range of information, and you're probably only going to be able to measure dry matter in protein. If you look at that region of the spectrum, you won't get information on the fiber fractions or the carbohydrates. So yeah, it is one of the most important questions to talk to the vendor about, really.
Sarah, here's a question about, I think, the scan example that you showed. The NIR force seems to only scan the surface of material in the bucket. So does the depth of the bucket not really matter?
Oh, the depth does matter. The scan goes down about 3 inches, I believe. So you do want to make sure you're using a deep enough vessel, and then also one that's dark. You don't want any light contamination to come through. As I mentioned, you can scan it multiple times. So in that particular video, you could see me smoothing over the sample in the beginning. I like to perform a couple scans, and each time I will fluff up the sample and present a new surface area.
Thank you for clarifying. If you are evaluating a dry alfalfa hay sample, how do you suggest processing that sample on the farm in order to properly scan it?
That's a good question. I mean, we would normally try and reduce the fiber length. So, use a pair of scissors or shears just to to cut it up a little bit to make it a bit more homogeneous when you put it in the bowl.
Any additions, Sarah?
Oh yeah, I'd agree with that. And then also just ensure you're not allowing too much light or any light to come in. So you probably can't approach a hay bale and scan it directly on the face. You'd probably get some light in that way. But if you cut it up with scissors and then have it in a nice dark bowl, that would work.
Okay. What is the average standard error of the prediction for NDF on corn silage?
Can't remember off the top of my head. It's somewhere around about 1.5, 1.7 units. But I can confirm that. But it's around about that. It's slightly less than 2.
Okay. And someone is asking, what is the wavelength range of the NIR4?
Again, that's 950 nanometers to 1650 nanometers, sorry, 950 to 1650 nanometers.
Okay. And maybe one of you could walk us through the process. So let's say someone decides to implement this technology on the farm. What is the process of getting the equipment and getting trained properly and how to use it?
So you'd reach out to us at Dairyman. We're the distributing partners for North America. So my email is here if you're interested from today. We also have information on our website. And then we would talk to you about the instrument. Right now in COVID times, we'd probably be doing some virtual training on best practices. And then we would ship it to you with all the attached paperwork and things that would be helpful for getting it up and running in your facility.
Very good.
And I think also, Sarah, you guys walk them through how to use the portal and work with that data, right?
Yes, we do. And support is ongoing as well. It's something we do a lot on our integrated farming team, offering software and hardware on farms. So this is something we're very familiar with, helping people troubleshoot and offering training materials as well.
That's great to hear. It's always good to have that follow-up and the opportunity to ask questions if needed. Someone is asking, would you please repost the formula for accuracy? I don't know if that's an easy thing to pull up.
Yeah, it's in the slide. I don't know. Do you make the slides available or? But
we can share that slide quickly. I think that will be the easier way to do it if you don't want to talk you through that. So we will, Kristen will get that ready here. And we're wrapping up the Q&A. So if anyone else does have a question they'd like to ask, please type that in now. Is this the slide, Chris, that would?
It's slide 13.
Slide 13.
Yeah, I'm missing a square root on that one. So it's a slide before that one.
Right there.
That's it.
Okay.
So it's 2 times the standard deviation divided by the square root of the number of samples you take.
All right. And someone is asking, some maybe extension or other institutions might not necessarily recommend NIR for on-farm purposes. How do we convince people that aren't believers maybe to utilize this technology and help farmers in this way?
I like to highlight that this isn't really meant to replace the lab analysis. This is meant to pair with it and get more observations. NIR technology has come a long way, and as Chris highlighted now a couple of times, the nanometer range on this device is fairly strong and robust, especially what's currently available in the market. And if they do have any questions, we do pair the purchase of an instrument with some lab analysis to help gain your confidence and be able to compare it back to our laboratory work. And it's just something we can always work with you on and help to raise understanding. I know it's a leap in some areas, but it's meant to be a partnership, not a replacement.
And you know, we do have a program. Well, Dairy One has a program where people can kind of test the unit for a period of time. I mean, they can ship out a unit, go through the training, and demonstrate and show them how to use it, and then they can actually use it themselves. And you know, sometimes that's the best way to gain confidence if you're a bit skeptical, which is understandable. But a bit skeptical is, you know, just to test it yourself. And certainly one of the comparisons is versus standard lab results, right? But it's also, as Sarah mentioned in one of her slides, comparing to what the cows are telling you. And at the end of the day, that's really what matters, because there's a fair amount of error in lab results as well. You know, if you remember Chris's slide. So it's just part of our world. But if that helps people increase their comfort level with the technology and with this product specifically, that's been a great way for people to address that.
Thank you both for adding some insight there. And our final question that has come in, the unit that was used in the demonstration did not have equations for alfalfa hay. Is that coming soon? Or if anyone can comment on that.
It does currently offer for both haylage and corn silage. The haylage calibration includes alfalfa mixed mostly legume or mixed mostly grass, and then grass silage. We also tried to expand the robustness of that one with a few small grain silages, just something to make the calibration a bit more diverse. The corn silage calibration has the best performance, but the haylage is currently included as well.
Okay, thank you.
I would add to that just very quickly. We continue to add, additional feedstuffs to the NIR for farm. Sorry, and the alfalfa is definitely one. More alfalfa calibrations is definitely one we'll be adding in the future. But you know, we kind of roll these things out over time, and it's important that we get a significant database of samples coming in before we can actually develop those calibrations so they're accurate when they're available. But that's kind of what goes on behind the scenes, with a unit like this. We continue to add to it and make it more valuable and more robust. So what's on there today is not what will be on there 3 months, 6 months, 12 months from now.
Very good, Bruce. Good wrap up.
Sorry, just to clarify a touch more. So the haylage and corn silage are currently there, and with the Dairy One bias added to them. And we do also have some grain calibrations now available. And I don't remember them all off the top of my head, but I know soybean meal and I think corn meal and maybe distillers are in there as well. I can't remember them all.
Yep.
All right, well, great. That was an excellent group of questions, and you guys handled them well. Once again, I'd like to thank Sarah, Chris, and Bruce for the presentations today and for answering all those questions that followed. For all of you in attendance, we thank you for your time and attention, and we appreciate your participation in both the polls and for asking insightful questions. As you leave the webinar, a short survey will pop up, and we would really appreciate your feedback if you would take a moment to fill it out. We hope you enjoyed this webinar, Real-Time Data for Real-Time Decisions, which was brought to you by AB Vista and Dairy One. On behalf of our crew here at Hoard's Dairyman and our partners, AB Vista and Dairy One, we want to thank you for your participation today. We send our best wishes to all for a safe and successful growing season and hopefully high quality feed as the end result. Thank you all.